When you deploy an autonomous AI agent out of the box, you are triggering thousands of hidden processes. Default configurations treat an autonomous agent exactly like a standard chatbot. They assume a human is sitting there, typing a prompt, and waiting for a single response. But an active agent operates continuously. It runs file checks, pulls environments for updates, and coordinates internal logic loops in the background. If you force a single frontier model, like Claude Opus, to process every one of those micro-interactions, you pay premium API rates for thousands of invisible, routine checks. Running an agent 24/7 is mathematically impossible to scale unless token management becomes a core piece of your infrastructure. Exponential token burn is an architectural flaw. It is a problem you solve by changing how the system operates. By restructuring the deployment, you can reduce a standard $150 monthly API spend to under $10 a month. This drop in cost relies on three core pillars: aggressive model routing, context isolation, and prompt caching. We define this systemic methodology as the 8-layer optimization stack. Mastering this stack moves an AI deployment out of the expensive experimental phase and turns it into a highly reliable production system. The first hidden token sink is extended reasoning, frequently labeled as thinking mode. Routine execution tasks like checking a file status or running a bash command require zero deep reasoning to succeed. Yet, by default, the model generates thousands of hidden reasoning tokens before outputting a simple yes or no. This animated diagram of a code editor shows the exact fix. By injecting the syntax thinking type disabled directly into the OpenClaw.json file, you instantly sever that hidden token burn. The second major sink is the continuous heartbeat. Agents use these automated cron jobs to poll the system and check if they have new work to do. A 60-second polling loop triggers 1,440 daily API calls, creating a continuous dollar loss. You fix this by rerouting all heartbeat polling to a local Olama instance. The system maintains perfect uptime and the cost drops to zero. Eliminating invisible, automated API requests is the non-negotiable baseline. You cannot scale agent logic until these leaks are sealed. With the leak sealed, we move to architectural model routing, a tiered, specialized approach to deployment. The top tier is the brain. This restricts premium models like Claude Opus or Sonnet 3.5 exclusively to high-level orchestration, strategy, and planning. An incoming task cleanly splits. Logic requirements route up to a brain node, while standard execution tasks route down to a muscle node. The orchestrator actively scans data packets, flicking a switch to assign the exact tier, accomplishing operational tasks at a 12 times lower cost. Using one monolithic model guarantees budgetary waste. Tiered routing ensures you optimize the return on investment for every single task. The next architectural hurdle is context bloat. Every time your agent makes a background API call, it resends massive system prompts and reference files. We bypass this using API-level prompt caching, which allows the server to store those large instructional prefixes in its memory. By separating base from cached token costs, cached context prefixes drop your input costs by 90%. You must keep static instructions locked in a green cache zone, while keeping recent variable chat logs cycling through a separate red dynamic zone. Even with caching, conversational history will bloat over weeks of continuous uptime. You have to maintain lean end-of-session memory logs. You configure the agent to summarize and compress its decisions at the end of each session, rather than forcing it to constantly load full historical transcripts. Strictly managing what the LLM has to read dictates your overall costs just as much as optimizing which LLM is doing the reading. The final massive token penalty occurs when a system spawns secondary subagents. This action alone can apply a 3.5x multiplier to your costs. By default, subagents inherit the massive, bloated context window of the parent orchestrator that spawned them. The architectural solution here is context isolation, executed via the /spawn command or dedicated context engine hooks. Instead of a bloated parent memory block duplicating infinitely, the spawn command creates a blank slate memory space. You isolate the coder node to pull exclusively from a GitHub database, fully walled off from the parent agent's unrelated email history. Establishing absolute data boundaries between agents prevents exponential token scaling in complex workflows. When you assemble these discrete layers, you get the complete, unified 8-layer token optimization stack. This node graph shows the optimized architecture running smoothly. Local heartbeats trigger the system, the brain delegates, and isolated muscle agents execute using cached prompts. Token flow is perfectly contained. This drops the operational cost from $150 to $10, demonstrating absolute financial stability. This level of infrastructural discipline is the definitive dividing line between amateur experiments and highly resilient enterprise deployments. This structural efficiency pushes past basic cost saving. It expands what you can actually build. By recovering your API budget, you unlock the capital required to scale a single assistant into a fleet of 10. Specialized swarms of these AI agents can be deployed to handle complex, multi-stage business pipelines entirely autonomously in the background. Operators who fail to optimize at the infrastructure level will ultimately be priced out of running continuous autonomous systems. The true power of an AI agent lies not in the frontier model itself, but in the efficiency of the architecture that surrounds it.